Hello, welcome to By Excellence Tutorials. Well, have you yet subscribed to the YouTube channel? If you've not yet subscribed to the YouTube channel, you're missing a lot. Subscribe to the channel, and also don't forget to click on the notification bell so that you get notified each time I upload new content. And if you happen to be looking for a tutor of mathematics, chemistry, physics, linear algebra, classical mechanics, you can get in touch with me on the contact details that I've dropped in the description box. Okay, so today we are dealing with this question. I think this must be dynamics, that's do with dynamics or linear momentum. Okay, so it says a bullet of mass 0.025 kg hits and is embedded in a block of mass 1.35 kg. The bullet block system moves a distance of 9.5 meters before coming to a stop. Find the speed v of the bullet before hitting the block. Coefficient of kinetic friction between block and the surface is 0.25. Okay, so I'll just try to illustrate something here, a quick one. So let's say a bullet has been fired in that direction and is moving in that direction, and you have something like a block that is stationary here. Okay, so this is a bullet of mass m and a block. This is before. Okay, I just want you to get the concept that is happening. Now after you have something like this, we are told that the bullet gets embedded in there. So the mass here is going to be the mass of the block and the mass of the bullet, because it has gotten embedded. So this is what we have. Now, before this bullet strikes here, we know that here the initial velocity is 0 meter per second. It's at rest. And over here, the speed, I'll say u with a small letter b as the initial speed of the bullet, we don't know, and that is what we want to find. Now, after moving here, after the collision, we also don't know the speed at which the embedded block bullet system moved with. Okay, so we need to know that velocity as well. Okay, now we've been given something here. Also, I'll do like this. I'll draw like this. So this is after collision. So now, what we're going to have, the forces, we have the normal force, we have the weight. So the weight is going to be m plus m times g, like that. And then since we are saying it has been hit in this direction, as the bullet is going in that direction, then this block is going to move in that direction. It's going to move in that direction, a distance of 9.5 meters. And then since it's going to move in that direction, then friction force is going to be in this direction. So we have the friction force like that. Okay. So I think you've gotten the idea now. So I'm going to start with using conservation of linear momentum. Okay. From the conservation of linear momentum, we have the mass of the bullet, or the momentum of the bullet, plus the mass of the block, and the speed of the block should equal to. Now here we have embedded system like that, m plus that, and then multiplying by v, which is going to be the speed. Now, a bullet is the one that was moving, and the mass of the bullet is 0.025 kg, multiplying by ub, which we want to find also. Now, this was at rest. Okay, this was at rest, so it's not moving, so it's 0. So we don't have momentum, initial momentum for this. And then we have equal to summation of 1.35 plus 0.025 times v. So we are going to have 0.025 ub equal to 1.3 75 v. So that is our equation 1. So we have that. Now, since this is what we have, we also look at, we need to get that velocity. Now, how do we get that velocity? So, look at that one. We have, from the diagram, we have the normal force equal to m plus m g, which is going to be basically 1.375 times gravitational acceleration, which is that. So the normal force here is going to be no, I don't think I need to calculate this. I don't think I'll need to calculate this. Let's just know that we have the normal force. That, you see why I'm saying so. And then we also have to establish the relationship also of the friction force here and the normal force. So we know that friction force is going to be given by coefficient of kinetic friction times normal force, which is just that, m plus mg. Okay, so that is my friction force, and that is my equation 3. Okay, so I'll say, let me erase here. I guess I have all the needed information. Okay, now we know that according to Newton we have that. Now the force that is causing motion is the friction force there. Okay, so we're going to have acceleration equal to over m, like that, of which here we have friction force over m plus capital letter M. Okay, the total mass of that. So we are going to have acceleration equal to, the friction is this one, which is mu k m plus m g. That is the friction force over m plus m. So m and that, those m's or the masses cancel, and the acceleration is basically the coefficient times gravitational acceleration. Okay, so we have established that one, and we know now from kinematics, that will be now from kinematics, we have v squared minus u squared equal to a change in distance. Okay, so now v squared is what we want now to find after the collision. How far did it, not how far, at what speed did it move? Because we know already how far it moved was 9.5 meters. So we are going to have v squared equal to, it was at rest, okay, 0 squared equal to 2 times mu G delta H. So V squared is going to be equal to 2 times, what was our coefficient of friction?
0.25.
0.25. And then G is constant, 9.81, and the distance, 9.5 meters. So V squared is going to be 2 times 0.25, 9.81, 9.5. So we have 46.5975. V, we square root both sides. We're going to have V as 6.83 meter per second. So after collision, after the bullet embedded, this system moved with a speed of 6.83 meter per second for a distance of 9.5 meters. So now we get this into the first equation. So first equation is like this: 0.025 UB equal to 1.375 V. Okay, so this is the V that we were finding. So we want to find now the initial speed of the bullet before it struck in the block. So we're going to have 0.025 equal to 1.375 times 6.83. Okay. We divide both sides by 0.25, 0.025, so that our UP is going to be going to be 375.4 meter per second. So the bullet was really moving at a faster speed of 375.4 meters per second to make sure that it strikes into that that block, and to move that distance of 9.5. So this is how you get that one. Yeah. So see you in the next video. I hope you enjoyed.